Welcome to July 16th LeetCode challenge for sum. Given an array nums of n integers, return an array of unique quadruplets nums a, nums b, nums c, nums d, such that a, b, c, d are between it could be equal or greater than 0 but less than n, or a, b, c, and d are distinct, so they're different numbers. And the sum of the nums a, b, c, and d at the sums of those are equal to the target. So we have you may return the answer in any order. So we're given an array nums example 1 here, and we have the target sum of 0. So you want to return a quadruplets of unique numbers that sum up to be 0 that are that are unique or distinct. So for example, you could have -2, -1, 1, and 2, which are unique numbers in nums. There are 4 of them, they add up to 8. Likewise, there's -2, 0, 0, 2, which are, notice how 0, this 0 is represented by this 0 here, and this 0 is represented by this 0 here. So they're not necessarily different numbers per se. They're distinct, as in there's a matching between in nums to the output, and they sum up to 0 as well, and this sums up to 0. So pretty much we could use any element inside nums to make our target. For instance, this has it has 2, 2, 2, 2, so the combination could be any of the 2 that sum up to 8, and this is a quadruplet as well. So basically, the output itself is returned in any orders, but it's kind of like a set itself as a set. So each of these are unique, right? But the order doesn't really matter that much. So with those two examples in mind, let's look at the constraints here. We have the length of nums is between 1 to 200, and the numbers itself could be really small, really big. Target itself could be really small or really big. So yeah, this question is actually probably listed as medium, but I found it actually quite a bit difficult. The question itself, I think, is built on other questions like two sum or something like that. So first, initially, I'm thinking that what we should do is so we have an array here. First thing we do is I think it'd be a good idea to sort the array. Go sort it. I might as well just nums.sort here. And then what we're gonna do to it. So obviously, we want to iterate through nums, and we're gonna use let's go from yesterday's example. You're gonna use 2 pointers. So we're gonna have 2 pointers pointing to the numbers, and then we're going to say, for instance, index I and index j. We're gonna point the two pointers, and we're gonna iterate through them and find a combination of I and j, such that if it fills we have a left pointer and a right pointer, let's call them left and right, where it's going to fulfill constant properties. First of all, it has to be equal, the sum has to be equal to target. And yeah, that's pretty much it. Let's kind of work through that. So we'll sort the nums first. We'll find we'll iterate through the first of all, let's kind of find the length of nums. We'll iterate through the combinations of nums at index I and j. We're just gonna find out fixed numbers for those two that are unique. And then by using 2 pointers, we're gonna have a left pointer and a right pointer, and then we just basically want to find the remaining value of the target minus numbers at index I minus numbers at index j, and then we're going to find the remainder, and then we're going to use that remainder to tell us whether we have hit the valid quadruplet that we want or not, and then we're going to do something to that. I'll walk through it and let's see how it goes. So we have an output, that's our set. So we're going to iterate through for I in range n, so we want to do is we don't want to iterate through I and j times. J in range of I plus 1. We want to be within our range here. All the way to n. Recall that the range we want is between, no, not that, right. Alright, and we are going to define a couple of things. So we're going to define a left pointer. Why is this like that? There we go. Left and right pointers. Those are going to be assigned to j plus 1 and n minus 1. So why is this? So left pointer is going to be the left element, pointer to the left element, any left element, and right pointer is going to point to n minus 1 element, so which is last element. So next we're going to have we're going to define our condition here, a condition that we need to meet, which is this right here, the target. We're going to do it, and I'm going to use a slightly different way. So we're going to have a variable called remainder, or main, where it's going to tell us the target minus nums at index I minus nums at index j. So this is going to tell us whether we have reached our target or not. So for example, if we have it's going to tell us we're going to use two pointers, and this is going to tell us to basically whatever remainder is resulting. That's going to tell us whether we need to move a pointer or we're going to return our value, because we have the correct valid quadruplet. Yeah, let's go with that. Let's see. So let's go to the while loop now. This is actually becoming a n. I'm just looking at the time complexity for now, but we'll do that later. Left is less than right. I'm gonna keep our pointers in the right direction here. If nums of left plus nums of right equals remainder, then we're gonna append our output, or add our output, I should say. So this condition is true if the left pointer nums plus the right pointer nums equals the remainder, which means that it's the remainder. It means that the target minus nums at I minus nums at j. That means that this is a valid quadruplet. That means we're gonna add the 4 numbers to our output set. Nums j nums left nums right. I have to add a set of, I think that might work. No, they don't need a bracket. And then we want to increment our left pointer and our right pointer, so we're going to increment it by 1. And then we're going to increment our right pointer by, decrement our right pointer, I should say. So we're moving from left pointer to the right, and we're moving the right pointer to the left, essentially. So if nums plus nums left and nums at index right equals the remainder, then we found a valid quadruplet. Else, if nums left plus nums right is greater than the remainder, that means the sum is greater than the remainder. That means that we have to decrement the right counter by 1, essentially, because this is not the target we're looking for. If left plus right nums right, I should say, is greater than the remainder, then decrement the right pointer by 1, else left pointer gets incremented by 1. Return output. That's overall looks pretty complex. Might as well run it and see if it works. Nums J. Okay, let's see. Sort the nums, assign n, assign output set, do a for loop for I to n in range n, do a j in range I plus 1 to n, for left and right, j plus 1 and minus 1, remain equals target minus nums I minus nums j, while left is less than right, if nums left plus nums right is equal to the remain, then the output is added to nums I, j, l right, increment left, decrement right, else if left plus right greater than remainder, decrement right, else increment left. Return output. There you go. Submit. Alright, accepted. So essentially I walked through the code. The first thing we want to do is, so the approach we're going to use is sorted, then using 2 pointers. So we sort the numbers, find the length, put our answers in output set because each answer is unique. Then we're going to run through a for loop here, nested for loop to find index I and j, such that those are going to be 2 numbers, two of our iterations. And then we're going to do 2 pointers for each iteration. Then while our left is less than right, that means that our left pointer is on the left side and our right pointer is on the right side. That's true. What we're going to do is if nums left and nums right, so the 2 indexes are equal to the remainder, that means it's a valid quadruplet. Else if nums, and then we increment our pointers, else if left nums plus right nums is greater than remainder, then the sum is bigger than what remains, then we want to decrement our right pointer, so we're going to move on. Notice how we don't add anything in these 2 conditions. So else if our nums left plus nums right is greater than remainder, that means we have less than what we're expecting, then we move our left pointer. So essentially we iterate through I and j, and we're going to move our 2 pointers each time, and then we basically add it to the output if this condition is true. So it's iterating through n times, and then at max n times. So this is n. Time complexity would be a big O of n to the third. Yeah, n to the third. Space complexity. It's using so since we're using sorted nums array, the space complexity actually reduces down to big O of log n times, because we're storing everything in a set as well. Alright, this question was actually quite difficult. It's a lot of maneuvering, and I wasn't familiar with the first question, but it's understandable, but it's not something that I would have gotten right away or understood. Like, it took a while to wrap my head around, at least. All right, that's it. Have a great day.